absolute value functions and how we can build them as piecewise, and then answering some really nice questions about them. So, all right, so we have this first one here, and we're given this equation, and we have h of x is equal to -1/2 times the absolute value of 5 plus 3x plus 1. And we're using that to answer the following questions. Now, before we do anything, I want to graph it because I think it's important to find out what this thing looks like before we go on. So remember, you always want your coefficient of x to be 1. So there's a 3 here, so we're going to have to factor out a 3. And by the way, the other thing is this is negative, so that should alert you to the fact that this thing is opening down. So we've got a couple of things here. So we're going to factor out a 3, and then we're going to go ahead and do what we got to do, and then we'll start answering all these questions. So I'm just going to march off to the side here. So if I factor out a 3, I get -3/2 times the absolute value of 5/3, plus x, and then minus plus 1 over here. So what you can write is x plus 5/3. So that means the vertex of this thing is going to be -5/3, comma 1. And this is, -1 2/3 if you want to look at it from that perspective, comma 1. Okay? So if we go and graph this, so if this is 1, we'll call that 2 just for fun. And then, 1 here. So it's going to be about there. So this is going to be -1 2/3, comma 1. I hope you're doing this on graph paper, which I should be doing, but I'm a little lazy. And our slopes are going to be 3/2 and -3/2. So remember, if that coefficient of x isn't 1, you got to factor it out to figure out what the actual slopes of these two lines are going to be. So this tells me we're going to go down 1, 2, 3. So we're going to go down 1, 2, 3, and to the right 1, 2, somewhere over here. And then down and left 1, 2, which is somewhere over here. So we're going to have a graph that looks something along the lines of this, okay, where this is -1 2/3. Again, you should do it on graph paper. Be better than me at this, please, okay? So when we want to find h of -8, -8 is actually going to be on this line, but just so you know, but it doesn't matter. But we can find h of -8 by simply substituting it into the equation, and that's going to be -1/2 times the absolute value of 5 plus 3 times -8 plus 1. Following your order of operations, you treat absolute value as if it's a parenthesis. So this is -24 plus 5 is -19, but the absolute value of -19 is +19. So now we're doing -1/2 times 19 plus 1. So that's going to be -5 times 19 plus 1. And that should give us h of -8 is going to be equal to -8.5. So somewhere on my graph down here, if I, it's got to be going all the way down, but I need space to work on this other stuff here. Hannah says that the point symmetric to h of -8 is h of 11. Is she right? Well, let's see. So I don't know. I'm going to say I don't know, but if I go out to where x is going to be equal to -8, we have to figure out how far is it between -8 and -1 2/3. So you're technically doing -8 plus 5 divided by 3. And that distance away is -6 1/3. So if I'm going -6 1/3, so this is 6 1/3 units that way, which means you have to go 6 1/3 units in the opposite direction. So we're going to be doing, -5/3 plus 6 1/3, which is 19/3. That is going to be 4 2/3. So that is not true. So it's going to be 4 2/3, comma, -8 is going to be the point symmetric. So this is no. Okay? True or false, it says h of x equals 2 will have no solution. So let's really think about that one. So when I say h of x is equal to 2, h of x is y. So we're saying y equals 2 will have no solution. And if I were to draw a horizontal line here, as I'm drawing this horizontal line, this line here is, in fact, y equals 1. And I'm asking you to tell me, where does that graph cross y equals 2? And when we say it's no solution, here's your physical answer that no, it's not going to have a solution. But let's find out algebraically why it's no solution. Okay? So let's go ahead and do this, shall we? So we have that 2 is going to be equal to -1/2 times the absolute value of 5 plus 3x plus 1. First thing we're going to do is subtract 1 from both sides, and we're going to get 1. So we get 1 equals -1/2 times the absolute value of 5 plus 3x. Now we're going to multiply both sides by -2. So -2, multiply both sides by -2 or divide by -1/2. It's the same thing. And you wind up with this. I want you to take a step back and look at that. And when you take a step back and look at that, I want you to tell me why there is no real solution for that. Okay, I should actually put no real solution. Okay, there's no real solution to this, right? Because when you take the absolute value of something, it should always be positive, and this came out to be a negative. So this is telling you that there is no solution, okay? And that's another way of saying no solution. So when you have that, that's another thing that's going to allude you to that. Okay, so now when we look at this one over here, and I ask you guys to write this as a piecewise function, again, we want to find the equation of this line, and we want to find the equation of that line. And like I said on yesterday's video, it's as if you're just going to create the two equations by making this inside positive and making it the inside negative. So if I go off to the side, I'm going to have my -1/2 times my 5 plus 3x plus 1, and then my -1/2 times the negative of the inside, noticing I'm using parentheses, okay, plus 1. All right, so what I'm going to do is watch this. I'm going to get this so that we know that this is the part of the graph that we're talking about. So we have this over here. And so when you look at this, if I distribute this through, right, and you guys can go ahead and clean it up, but I am super lazy. This you'll get -5/2 minus 3x, and then plus your 1. You can combine all your stuff here. But I see it as, you know, all right, I'll do it. All right, so -5/2 minus 3/2 x plus 1. So -5/2 plus 1 is -3/2. So I have -3/2 x minus 3/2. And then this one over here, this is going to be -5 minus 3x, which I'm going to be multiplying by -1/2. So that's going to be 5/2 plus 3/2 x plus 1. And if I add 5/2, so that's going to be 7/2. So then this is going to be 3/2 x plus 7/2. Now, remember, the restrictions on the lines are based on where the x coordinate of your vertex is. So, and it's at 1 2/3, so we're going to do x is less than 1 2/3 or -5/3, because it's easier to write, and then x is greater than or equal to -5/3. And remember what I said, it doesn't matter if you put the equal sign here or here, you get to pick and choose. But let me just make sure that I'm saying and doing this right. No, this is backwards. This should be, because take a look at what I did. Take a look at what I did. It should be the other way around, because if I'm going to be using the line with the negative slope, it's actually this side when it's, when it's greater than that. And then this is when it's going to be less than or equal to, because this has the positive slope. So when you're putting in your restrictions, be careful, okay? Because I'm glad I made that mistake, because then that way you guys don't do that, all right? Okay, it's asking you at what points do these two functions intersect. So you have this absolute value function, and then g of x equals -6. So you have a v and a horizontal line intersecting. So we're on the hunt for these 2 points of intersection. So we have -4/5 times the absolute value of 2x minus 3 plus 2, and we're going to find out when that's equal to -6. And because they do intersect, we actually do have real solutions. First step is we're going to subtract 2 from both sides to give us -8, and then multiply both sides by 4/5. So I'm going to have the absolute value of 2x minus 3 is equal to -8. So that's negative. So that's 32/5, I believe, right? Yeah, so it's going to be 32/5. So when you solve an absolute value equation, you wind up with two different equations, because, again, inside can be positive or negative. So you're going to have one equation where it's 2x minus 3 is equal to 32/5. The other equation is going to be the opposite of 2x minus 3 is equal to 32/5. Because, again, inside, that absolute value is magical because it's your distance away from wherever you are. And that's why it can be either positive or negative, because it has to do with the distance. So these are the two equations, the positive one and the negative one. So this one over here, we're going to add 3 to both sides and divide by 2. Over here, I would divide both sides by negative and then go through my usual shenanigans here. So this would just be 2x minus 3 equals -32/5. I think when you guys were learning how to solve absolute value equations back when you were in like Algebra 1, they're like, make it both positive and negative. That's not what's positive and negative. It's what's inside the absolute value that's positive and negative, which reserves the right to say, okay, now I can divide both sides by -1. So I just want to make sure that you understand that it's the inside of the absolute value that gets to be positive and negative. And that's why when I divide both sides by negative, I can now say that I can set my equations to be equal to the positive 32/5 and the negative 32/5 because I'm accounting for the fact that that can be positive and negative. So when I go ahead and solve, so hold on, so 32/5 plus 3, divide that little fucker by 2. This one is going to be x is equal to 4.7. Okay. X is it? X is equal to 4.7. That doesn't look right. You know why? Because this shouldn't be 32/5. It should be 44. That's 10. Oh, Charlene. Oh, rookie mistake. I bet you guys were probably saying that the whole time, weren't you? You're probably like, wait a minute, Schwa. You're doing something wrong here. But I like how I looked at that, and I'm like, that's not making any sense, so I know I made a mistake somewhere. So, ooh, I like that I'm making these juicy little mistakes for you. You're welcome in advance. Okay, so let's go back to solving. This is what happens when you try to cut corners. That's going to be -8, right? So that's going to be -8 times 5/4. So -8 times 5/4. Jesus, Mary, it's going to be -10, right? So or positive 10. So this is going to be equal to 10. So this turns out to be very nice. Actually cuter than I had originally thought. Likely. So now I have 2x is equal to 13. So then x is going to be equal to 6.5. Makes a lot more sense, okay? X is equal to 6.5. And then again, 2x minus 3 is equal to -10 because I can divide both sides. And then I get 2x is equal to -7. So x is equal to -7/2, which is equal to -3.5. So when I look at these ordered pairs, this makes a heck of a lot more sense than what my original one was. So when they ask you for the points of intersection, it's going to be 6.5 comma -6 and -3.5 comma -6. So just be careful. You can see how careless I'm getting, but you know, save me. Okay. So you want to write the absolute value from this function, okay? So if we want to write the absolute value of the function, the first thing we need to do is find out what the vertex is. And it looks like this is, that's -1 there. Be careful. Ooh, I almost fell for that too. I almost fell for it again. So this is going to be -1/2 comma -2. And then if I want the slopes of my lines, right, this is where the hard part comes in because this right over here is 1, right? This is 1. So if I look over here, these are going up, my x's are going up by 1/2, but my y's are going up by 1s, okay? So that, you hear what I just said? My x's, no, oh, everybody's going up by 1/2. So here we go, everybody's going up by 1/2. So, right, because that's 1/2 and 1, and then that's -1 here. So 1, 2, right? 1, 2.5, or 1.5. So this is going up. So when I do my slope, I'm actually going up 2, but I'm going to the right. Take a look at this one. I'm going to the right 1.5. So my slope of these lines is going to be 2 divided by 1.5. And if you leave that as a fraction like that, or with a decimal, I'd smack you. But the way to change it is to multiply top and bottom by 10. And then you can just go ahead and simplify this to be 4/3. So the slope of this line is 4/3, which means the slope of this line is -4/3. So those are going to be my two slopes when it comes to writing my piecewise function. However, now that I am ready to go, my vertex is at -1/2 and my -1/2, -2. So now I can just do f of x is equal to, because I know what the slopes of my lines are 4/3, and then I could do x plus 1/2 minus 2, okay? And I know it's going to be positive, by the way, boldly, because this is opening up, so it's not going to be a -4/3. So now, when I want to go ahead and write the equations of my two lines, oh my goodness, it's so easy because I have my vertex, and that's the x that's going to help me with my restrictions over here. And I have a negative going this way and a positive slope going that way. So if I do point slope, because you know I'm going to, so you guys could do what you want, but I'm doing point slope, okay? Plus 1/2 minus 2. That's going to be my first, get this out of the way over here, and 4/3 times x plus 1/2 minus 2. Because this line corresponds to this line here in point slope form. This one corresponds to that line, and this is when x is less than, I'm going to put equal to on this one, -1/2, and when x is greater than 1/2, noticing I have to pick and choose and then go with it from there. So now, we haven't done domains and ranges, but you know, if you look at your absolute value, your domain is just all real numbers. But your range is dictating what the vertex is doing, and you can see that it's going to be greater than or equal to -2. And the next one is saying to find f of 13, and then find the point symmetric to f of 13. So if we want to find f of 13, we're just going to do f of 13 is equal to 4/3 times the absolute value of 13 plus 1/2 minus 2. And remember, absolute values is actually like a parentheses, so that's 13.5. So if we do 13.5 times 4/3, and then subtract 2, we actually get 16. So f of 13 is equal to 16, and then they want the point symmetric. It says find the point symmetric. So again, everything is equidistant from the vertex. So out 13 from -1/2 is 13.5, which means I have to go 13.5 in the opposite direction. So I'm going to say 13.5. So -0.5 minus 13.5 is, you got it, -14. So these are the 2 points that are going to be symmetric to one another. And then it says find f of x when x is equal to 4. So in other words, we're trying to find out when y is equal to 4. So we're looking for these 2 points of intersection. So when we want to do that, we can go ahead and take our equation, and I'm running out of space here. Look at me. But what I'm going to do is erase some of the stuff so I have a little more space. Look at me go. I'm such a rock star. Rock star. By the way, as you're noticing, we're going to do this one when f of x is equal to 4. But what I want to show you is the next one when f of x equals 10 will be interesting. But let's do this one first. So we have 4 is equal to 4/3 absolute value of x plus 1/2 minus 2. So again, we're going to add 6 to both sides. Add 2 to both sides to get 6. I'm jumping the gun here. So I have 6 is equal to 4/3 times the absolute value of x plus 1/2. And so we're going to multiply both times by 3/4. Remember what I did last time? 6 times 0.75 is 4.5. So I have 4.5 is equal to the absolute value of x plus 1/2. Now, if you remember what I said to you, when you have the absolute value, there are 2 equations, because the inside can be positive and the inside can be negative. So you're going to have your 4.5 is equal to x plus 1/2. Oh, my pen is starting to go. And then 4.5 is equal to the opposite of x plus 1/2 because it can be negative, right? So when I solve this, I'm going to subtract 1/2. So here I get x is equal to 4. This I'm going to divide by a negative and then subtract, and that's going to be -5. I believe I am correct, and the picture actually tells me the story that I am indeed probably correct. So when you, yes it is, look over here, and if you look 4 straight up, so this is going to be 4, 4, right? It's 4 because the x is 4, and then this is going to be -5, 4. Okay, so those are my 2 points of intersection. Then I asked you to find x when f of x is equal to -10. So this is my graph, right? And so, whoops, yeah, this is my graph here. And it's asking me when the line x equals -10, which is like down here, intersects, and we can clearly see that it's not. So algebraically, we can show that there is no solution, and we can do it by doing -10 is equal to 4/3 times the absolute value of x plus 1/2 minus 2, and if I add 2 to both sides, I get -8 is equal to 4/3 times the absolute value of x plus 1/2. And then if I multiply both sides by 3/4, I'm going to get -6. So I get -6 is equal to the absolute value of x plus 1/2. When you look at that, again, in your beautiful minds, you should say to yourself, this is always going to be positive, and then so therefore this will be a no solution. This is never going to happen, so therefore we say no solution, because when you take the absolute value of something, again, it is a distance away. Distance is always positive. A distance will never yield -6, not in our real world. Okay, I hope you found this helpful, and by looking and doing it you guys should be able to figure out how to get some of the work done that I'm assigning you over the next couple days. You reach out if you need anything.